Here's our next proof. Again, another very common kind that you'll probably see in lots of textbooks in various forms. And this one is a little bit different. There's no angles in this one, it's just lines. So let's see what we can do, but we're going to follow the same steps. The first one is we're going to look at what it's asking us to prove. And the interesting thing about this one is it doesn't give you any given statements, which is kind of strange. So let's just look at the prove statement, and it says prove PR equals QS. Notice there's two letters here. When you refer to a line segment, you usually have a line over the top of them. These don't have them because we're talking about the measure. If you want to know how long a line segment is, you do not include the line over the top. So I need to figure out that these two lines are the same measure. Now I'm going to go to my next step, because this is fairly easy to understand. Talking about two line segments having the same measure, I want to draw my diagram to help me understand what I'm doing. And again, you should always draw all over your diagrams. Some teachers, including myself, will give you points just for writing on your diagram. So PR, that's this one right here, PR, and then QS is this one right here. And I need to prove that those two are the same measure. Now there's one other thing given to you that isn't actually explicitly written down, and that's these two little dashes right here. If you ever see a dash through a line segment, that means it is the same measure. So it tells you that PQ and RS are in fact equal. So I'm actually going to write that down right here. And my justification, as you can see, is given. It wasn't given in words, but it was given in the diagram. So if you see something in a diagram that's told to you, you can use the word given as another justification. So let's think about how we can actually break this down. What's our strategy? We know where we're supposed to go, but we don't know how to get there yet. So let's see if we can mentally figure that out together. I have two equal segments here. And then I'm adding this same piece. See how this overlaps between both of the line segments? If we use some numbers, it might be pretty easy to tell. So maybe this line segment is 5 units long, which would make this one also 5 units long. And the middle one, regardless, is going to be maybe something else. Maybe it's 3 units long. So that would make this 8 and this 8. They're the same measure because they added the same amount to both sides. This is another great strategy when you're looking at measures, is to plug some numbers in, and it will help you sometimes visualize what's going on. You can see 5 plus 8, or 5 plus 3 equals 8, and 5 plus 3 equals 8. You can see they're the same because I'm adding the same number each time. So that's something that's really helpful for me as well. So what I need to show on this is that I'm adding the same number to the same thing. That allows me to show that they're equal. So let's go ahead and finish this up. So I know these two are equal. And what I want to do is add this piece to both of them. So that's what I'm going to do. So see, I've added QR to both sides. Now, it doesn't look like it because I didn't use numbers or variables, I used line segments, but this is still the addition property of equality because I added the same thing to both sides of an equal sign. So that's my justification right here. I've already got my given statement. I've added the same thing to both sides. All I need to show now is that these two segments added together are the same as PR. And I need to show that these two segments added together are QS. And that one is an old standby. It's one of those ones you probably learned early on in the school year and you forgot about because it was so obvious you didn't even think you needed to remember it. But here it is in case you forgot. It's called the segment addition postulate. The segment addition postulate simply says you can add two pieces of a segment and it equals the longer segment. Now that we have the segment addition postulate, now I can say that PQ plus QR equals PR. Again, it seems so obvious, but we need to have good directions. We need to know exactly where we're going. Don't just assume that people can figure out where you're going. You need to be specific. So there's that, and my justification again is what I just gave you, the segment addition postulate. Now we're going to do the other side. That's what this side is. Now over here, I'm going to do the same thing. QR, this one, QR plus RS equals QS. And that's just this one right here. But remember, these were already equal to each other. So just like substitution on our last one, where we plugged one in for the other, I'm going to plug PR in for this whole piece. And I'm going to plug QS in for this whole piece. But since I'm doing a lot of substitution all at once, you can choose to do one at a time if you like, or you can simply choose to do one big substitution with lots of stuff at once. You can substitute in PR for this whole thing, and you can sub in QS for this whole thing. If you want to do multiple substitutions at once, we need to do, there's another property that allows us to do that. Here's a picture of it. It's called the transitive property of equality. And all the transitive property of equality says is that you can do multiple substitutions at once. So I'm going to put in the transitive property of equality right here. And as always, we want to finish our proof with QED. Now again, this looks complicated. You're like, but can't you just see? You got the numbers, right? Well, remember, when you're giving directions to somebody, you can't just assume that they know where they're going. You have to be explicit. And a proof is all about being very explicit, very specific about what different things need to go where, about where to turn, why you can do each individual step. And that's what makes proofs difficult. Again, learning all of these things and then seeing the route. But with practice, walking through examples like this, eventually it will start to click. You'll start to see these patterns reemerge again and again, and these problems will get easier. So thanks for watching. Please subscribe if you haven't yet. If I've been helpful for you, please do that. Or you can let me know in the comments on some other things that you'd like me to make videos of. Otherwise, I hope you have a great day. Next time, we're going to be talking about proofs that are a little bit bigger, and I'm going to show you another kind of proof that is not a two-column proof. It's called a flowchart proof. So we're going to do that next time.